So malaria kills about 500,000 kids every year.
Wow.
And so, yes, and obviously if drug resistance becomes a problem, then we're in danger of having another really major crisis. And the sort of stretch goal is for us to understand enough about malaria parasites to be able to model how they would behave inside a human.
Right.
Okay, so we might treat them with drugs in the laboratory, but what we really want to know is what would happen when that parasite experiences a drug in the context of a human.
Right.
And so you need to know something about the pharmacokinetics of the drug. You need to know something about the way the parasite sees the drug, the stage of the parasite growth, and you put all that information into a mathematical model, and therefore you can predict better ways to actually apply those drugs, so different drug regimens, which means that the drugs are more effective.
So what we put forward was that bacteria cause disease by producing what we call molecular weapons, virulence factors. And we had identified, again, what we would call the weapons assembly machinery. So by knocking out the weapons assembly machinery, we stop the bacteria from causing disease, and that means that the bacteria don't die, they don't stop growing, but they don't cause disease, which means that our immune system can then overcome the effects of the bacteria naturally, while the antibacterial does its job.
We've discovered that the grammatical system and the sound system are not really autonomous. They're not modular. There's a lot of interactions between those. If you think that there's a child who maybe doesn't have a good grammar of the language, the nature of the type of intervention one might do has to be responsive to where the problem actually is. So if the problem is actually in the sound system, that then has an impact on the grammar. If you're just addressing grammatical phenomena, you may not get very far. It may not be very successful.
Working on rice quality, a lot of our research delivered to the breeding program. So the breeding program we would say understand something about, for example, aroma in rice. We found one of the genes that increases the amount of that aroma. And so we then pass that on as a selection tool to the breeding program so that they can select for varieties that have high aroma for markets that want that. So that's the kind of research about aroma, starch quality, eating quality, sensory quality, the allocation of sugars to the grain to help with grain filling so that we don't get those little white spots in the grain that's called chalk. And so we get a high amount of grain that is whole grain after the milling process.